calibration. Why is my screen orange here? It's just weird. Okay, that's a little wider. Boy, that's really got an orange tint to it, doesn't it? All right, so this is actually number 19. Convert the equation f as a function of t is 190 times 0.07 t to the form f of t is ae to the kt. Zoom out. So it's actually really easy to do. Just do a lineup process. All right. A is 190. T is going to be t. But e to the k is in the same position as 7/10. That's really all there is to it. Just figure out what k is. So a is 190. Easy. And to do this guy, we would just ln both sides, right? So k natural logs of e is the natural log of 7/10. And k is simply the natural log of 7/10. Whatever that is. All right. It's a Milbrath-Math problem. I don't know, try that. Try rounding it to 8 decimal places, whatever. But that's how you do it. It's a pretty easy problem. I'm so tired of being interrupted today. Where was I? 1906. Oh, the earthquake problems. These are one of these. We had a 7.9. Same time there was an earthquake in South America. It was a 5.4. All right, so the deal here is that the magnitude is 2/3 of a log. Contains some intensity S1 over 10 to the 16th. So there's one of them. The other one's a 5.4. We'll call that intensity 2. Use a calculator here because I'm too tired to do this in my head. 3 times 7.9, cut in half. 11.85. Seems like the one we did in class, actually. 11.85 is a log. Understood base 10 of seismic 1 over 10 to the 16th. And what we'll do is we'll raise that to the exponential space. 10 to the 11.85 is intensity 1 over 10 to the 16th. I don't know what's up with my camera today for y'all. I don't know why it's being funny. Anyways, we'll multiply by 10 to the 16th. So intensity 1 is going to be 10 to the 27.85. The same kind of technique down here for intensity 2. We get 8.1. So 8.1 is a log base 10 of intensity 2 over 10 to the 16th. Anyways, just add those two numbers together. And intensity 2 is 10 to the 24.1. And it wants to know how much more powerful the San Francisco earthquake was. So we're just going to make a direct comparison here. 10 to 27.85 over 10 to the 24.1. Of course, we subtract decimals. And we get 10 to the 3.75, I think. Which is several thousand times stronger. There's two ways you can answer this. You can say it's 3.75 magnitude stronger. Which it is. 3.75 magnitude stronger. Or you can just, do this. 5,623.4 times stronger. And either I'm fuzzy or the screen's fuzzy. Something's fuzzy. All right, 17. Ooh, it's Newton's law of cooling. Roasted turkey is taken from an oven. All right, so Newton's law of cooling. How is your book teaching that? Your book is teaching this: temperature at time t is some constant that is dependent upon room temperature, e to the kt plus temperature of the surrounding medium. That's how your book teaches it, I believe. And this is a multi-part problem. So a roasted turkey is taken from an oven when its temperature is reached 185 degrees Fahrenheit. So what we have here is when time is 0, temperature is 185. So I can plug some crap in. So time as a function of t is 185. And I'll have AE to some constant times 0. And it's placed in a room where the temperature is 75, so the temperature of the surrounding medium is 75 degrees. Well, thankfully, it's AE to the K0. It's cool. It's 110 equals A times a 1. So there's my A value. That's the easy thing to get. Now temperature as a function of time is 110 E to the KT plus 75. To actually be able to use this thing, the only thing I need is K, because I can always plug in times. And let's see here. If the temperature of the turkey is 159 degrees after half an hour, what is its temperature after 45 minutes? So half an hour is obviously 30 minutes. So I'll plug a 30 in, I'll plug a 159 in, take it from there. 159 is 110 E to the 30K because time was 30, plus that's 75. Subtract 75, I think you'll be at 84. Seems right, but I'm really out of it today. 4-year-old decided to wake up at 5 a.m. Yeah, 84, which is fine because I was going to get up anyways. I just had a lot to do, and when you have a 4-year-old, you don't get to do a lot of that stuff. Divide out your 110. 42 over 55. Then we'll ln both sides. As tired as I am, I want to write this all out. All right, that's enough. So my K, my rate of cooling here, is a natural log of 42 over 55 divided by 30. So there she is. Negative 0.00898, blah, 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 blah. Anyways, I'm just going to store it to X. That's exactly what I'm going to do with it. Or you could actually store it to K. You could hit alpha. And where's that K key at? Parentheses. And there it is. It's in your calculator forever until you decide to put something else there. What's its temperature after 45 minutes? So the temperature as a function of 45 is 110 e to the K times 45 plus 75. And then you can just push buttons in the calculator. 110 e to the 45K and then add 75. Still pretty hot, isn't it? 148.4 degrees. Probably not going to eat that turkey. Find the time required for an investment of $5,000 to grow to $8,900. Oh, this is sorry. This is compound interest formula. The amount after time passes is the principal times 1 plus r over n to the nt. You guys should be comfortable with that thing. 5,000, 1 plus 0.075. You all right over there, Cora?
Yeah. I'm just going to ask you the rest of the questions.
We're going to grow to 8,900. So it's kind of ugly, but it's not a hard problem. Divide out your 5,000. 1.78, which is probably like 89 over 50. Yeah, it was. One plus 0.075 over 4 shouldn't be too bad of a decimal. It stops. It's only, what, 5 positions long? And hopefully you know the technique here. You just ln both sides. Alright, so divide both sides by 4 natural logs of 1.01875. So I got that natural log of 1.78 if you like the decimal. It's actually quicker to type in. Divided by 4 natural logs of 1.01875. Something seems wrong about that. Oh, I'm an idiot. Something is wrong about that. Parentheses. Knew something was wrong about it. Let me try that again. Parentheses. If you divide by 2 or more, you need parentheses. There we go. That's more reasonable. About 7.76 years. And that is going to be all the time I got for that. That stinks. I only got 4 done. So I'll do another video during my lunch break, which is about 20 minutes. That'll be all the time I can do for you. Just not enough of me. Sorry, kids.